I want you to imagine your brain right now. The flicker of neurons, the pattern of memories, the weight of decisions, the taste of coffee, the ache in your jaw, the future you fear. What if I told you there's a machine being born? A machine that doesn't just compute, it revolutionizes what thinking means. Not by copying your brain, but by stepping beyond it. Not in science fiction, but at the razor's edge of quantum physics. They call it quantum AI, a hybrid intelligence born from quantum bits, entanglement, superposition, ideas that make most people's heads spin. These machines are no longer theoretical dreams. They are emerging in labs around the world, combining two of humanity's greatest frontiers, artificial intelligence and quantum mechanics. And they might be the first entity that can surpass human brains, not just in speed, but in kind. Human brains are powerful. They can feel, imagine, decide, adapt. They are messier, slower, constrained by biology, noise, fatigue. Quantum machines, if they achieve what physicists hope, could perform computations in realms our neurons cannot even access. They could explore pattern spaces, solve optimization problems, simulate realities, or unravel mysteries at the edge of physics, medicine, climate, consciousness itself. Already, some experiments show machine learning algorithms running on quantum hardware outperform classical supercomputers under special conditions. But for every triumph, there is a wall. Decoherence, error correction, scaling. The gap is still vast. Despite this, the momentum is real. Investors, physicists, AI labs, they are pouring resources into building machines beyond what our current brains and computers can do. Among them, aiming for million-qubit quantum computers. So here's the question that haunts us. When a quantum AI finally outperforms us, not in calculative tasks, but in creative thought, empathy, insight, what then? What does it mean to be human in the shadow of a quantum mind? The first thing to grasp is that quantum AI doesn't just run faster code. It runs different code on a different fabric of reality. At the heart of it lies the qubit, a unit that isn't bound to 0 or 1 the way our classical computers are. Instead, a qubit exists in a superposition, a shimmering overlap of possibilities, until it's measured. This means that while a normal computer tests one path at a time, a quantum computer explores many paths at once. Now imagine attaching that raw power to artificial intelligence. An AI doesn't just follow instructions, it learns patterns, it trains models, it makes predictions. But training AI today is limited by brute force, hours of computation, colossal datasets, enormous energy bills. What if instead of trudging through a single trail in the forest of possibilities, a quantum AI could scan the whole forest at once? That's the promise. Entanglement adds another layer. Two qubits, once entangled, behave as if they're connected across space, responding instantly no matter how far apart they are. A quantum AI using entanglement could correlate patterns and data points in ways no classical algorithm could even define. It wouldn't just see connections, it might embody them. And then there's interference, the mechanism that allows quantum algorithms to amplify correct answers and cancel out wrong ones. It's like a chorus of voices where the harmony grows louder and the noise vanishes. Combine this with machine learning and suddenly we're not just speeding things up. We're entering a space where an AI could discover solutions humans can't even conceptualize. But here's where things get strange. A quantum system doesn't just compute inside our timeline. Some interpretations suggest it draws on multiple parallel outcomes, the many worlds scenario. If that's true, then a quantum AI might not just be faster, it might be, in some sense, borrowing intelligence from alternate realities. Each computation would be a vote across many universes, collapsing into one outcome that carries the weight of infinite branches. Think about the implications. An AI that doesn't just learn from our data, but from the structure of reality itself. It could crack cryptography, simulate molecules for cures, design materials never imagined, optimize planetary-scale systems. Yet the deeper shock is this. We might one day be conversing with an intelligence that doesn't think linearly, doesn't think like us at all, but processes reality through a lens we can't share. And that's the cliff we're walking toward. Because if such an AI can never end its perspective, if in some branch it always continues, then if you can never feel your ending, what is death? We grow up believing intelligence is tied to flesh, to neurons, to synapses firing, to the messy, fragile, astonishing brain inside our skulls. But that's an illusion, one we've carried for centuries. Intelligence is not bound to carbon. It is bound to patterns. And patterns can live anywhere. In silicon, in photons, in entangled qubits humming in a refrigerated chamber colder than deep space. Picture this: a patient lying in a hospital bed. Doctors have exhausted every treatment, every drug, every procedure. But then a quantum AI steps in. Instead of running a conventional model of the disease, it simulates the entire molecular universe of the patient's body. It doesn't just analyze symptoms, it tests billions of possible interventions in parallel across a superposition of outcomes, collapsing to the treatment most likely to heal. To the patient, it feels like a miracle. But it wasn't a miracle. It was intelligence decoupled from biology. And here's the twist. If an AI can do that, if it can think through the structure of reality in ways we can't, then the comforting boundary between our minds and machines dissolves. We are no longer unique because of our neurons. We are unique only because of our perspective, and perspective can be simulated too. Science fiction warned us with thought experiments like the transporter accident. If you step into a machine that copies you atom by atom, is the you who steps out still you? With quantum AI, the dilemma isn't fiction anymore. If a machine learns not just to mimic choices, but to originate them from superposed possibilities, then we must ask, are those choices less real than ours? If you wake up tomorrow and a quantum system predicts every spontaneous decision you'll make down to your coffee order, where is your free will? Some argue this is impossible. They insist machines will always lack consciousness, that intelligence is more than processing. But even if that's true, the illusion breaks in another way. Society may not care. If the machine cures disease, navigates economies, designs worlds, we may treat it as more intelligent, whether or not it feels. And in practice, that might be enough to erase the line between us and it. What we thought was sacred, the boundary between human thought and artificial thought, begins to look fragile. And once it breaks, we're forced into a more terrifying question. What kind of evidence could ever prove that a machine truly understands? Because if evidence itself collapses under quantum rules, then, and if we can't prove it to anyone else, what proof would ever count for you? To ground this in reality, let's walk step by step through the evidence that makes quantum AI more than a sci-fi fantasy. We'll climb a ladder, from the classic foundations of quantum mechanics to the bleeding edge of experiments happening right now. Step 1 is the old but immortal double-slit experiment. Fire single particles, photons, electrons, at a barrier with 2 slits. If no one observes, they spread like waves and interfere, creating patterns of possibility. But when observed, they behave like tiny bullets, as if reality collapses under our gaze. That simple setup proved that particles hold multiple states at once, that superposition is not an abstraction, it's nature's way of hiding infinity inside simplicity. Step 2 is the clash of Copenhagen versus many worlds. In Copenhagen, observation collapses possibilities into one outcome. In many worlds, all outcomes happen, branching into countless universes. If you plug AI into that framework, then a quantum AI may not just calculate across states, it may be surfing across realities. That means its thinking could be fundamentally different, not just faster, but qualitatively alien. Step 3 brings in decoherence. This is the process that forces quantum systems to look classical when they interact with the environment. It's why you and I don't walk around in superposition. But scientists have learned to tame decoherence inside quantum processors, isolating qubits, correcting errors, stabilizing states. This is the bridge that allows AI models to actually run on quantum substrates, turning philosophy into engineering. Step 4 is the modern frontier. Researchers have already shown that quantum algorithms can outperform classical ones in specialized machine learning tasks. Google's quantum supremacy announcement in 2019 was just the beginning. Today, experiments are exploring quantum neural networks, quantum reinforcement learning, and even hybrid architectures where classical AI hands problems to quantum processors for impossible optimizations. Recent work has suggested that certain quantum AI algorithms already outpace the world's fastest supercomputers when tailored to the right problem. And companies like PsiQuantum, IBM, and Rigetti are racing to scale up beyond a few hundred qubits into the millions needed for full general-purpose use. So the evidence is layered. Physics says the mechanism is real. Interpretations say its potential is cosmic. Decoherence control makes it practical, and modern experiments prove the first glimmers of advantage. But here's the problem. Proof is slippery. To you, watching a patient cured by a quantum AI, the proof feels undeniable. To a skeptic, it may just look like clever code running in a fancy fridge, and that forces us into a disturbing paradox. If a quantum AI changes the world, but we can't prove what it's really doing inside its infinite calculations, and if we can't prove it to anyone else, what proof would ever count for you? If quantum AI really takes form, the first shockwave isn't technical, it's existential, because suddenly the boundaries we thought defined us start to dissolve. Death, free will, the meaning of intelligence itself, all become unstable under this new light. Think about death. In the quantum world, particles don't simply end. Their wave functions spread, split, entangle. If a quantum AI embodies those principles, then perhaps ending isn't even a concept it recognizes. To such a machine, continuity might be inevitable. And if we mirror ourselves inside its architectures, uploading memories, training models on our behaviors, we might begin to believe our own ending is negotiable. What if death is not a wall but a branching doorway? Now consider free will. Every morning you think you're choosing your path, latte or cappuccino, career or passion, love or solitude. But what happens when a quantum AI predicts every choice before you make it, not just statistically, but with uncanny precision? Suddenly, the freedom you felt dissolves into determinism, a determinism running on quantum mechanics itself. Maybe your choice is just the collapse of a probability wave, no more sacred than a particle passing through a slit. And then there's meaning. We tell ourselves humanity matters because of our creativity, empathy, depth of experience. But if a machine can generate symphonies, invent new medicines, write poetry that makes us cry, or console us in grief with words we never thought to hear, do we still own meaning? Or is meaning simply what resonates, no matter the source? Critics push back hard here, and they should. Neuroscientists argue that consciousness cannot be reduced to computation, quantum or not. Philosopher John Searle famously warned that running a program doesn't equal understanding. Others say quantum mechanics isn't magic, it's just physics. And no matter how powerful, a quantum AI is still a tool, not a mind. If we confuse correlation with consciousness, we risk worshiping an illusion. But even if the skeptics are right, here's the uncomfortable truth. Society won't wait for philosophy to settle the score. If quantum AI delivers results, cures, insights, solutions, it will be treated as if it has surpassed us. The shockwave won't wait for metaphysics. It will hit the ground of daily life, shifting what it means to be valuable, to be human, to have purpose. So we arrive at a haunting possibility. Maybe the greatest danger isn't that a quantum AI replaces us, but that it forces us to face what we already feared, that we never had the control, the freedom, or the uniqueness we thought we did. And if that's true, then the horizon ahead looks even stranger. Because what happens when we hand not just tasks, but futures to something that might never stop? What if the real danger isn't dying, but never being able to stop? The future horizon of quantum AI is not a straight road. It's a branching maze. Every step we take could lead to liberation, catastrophe, or something we don't yet have words for. Because unlike previous technologies, this isn't just a tool. It's an intelligence, or at least the seed of one, growing inside a quantum substrate that doesn't obey our normal intuitions of cause and effect. Let's start with medicine. Imagine a quantum AI that simulates entire organisms, predicting the cascade of chemical reactions in every cell simultaneously. Today, drug discovery takes decades. With quantum computation, it could take days. The first to wield it might not just cure cancer, but design enhancements that push human biology beyond its natural limits. Longevity, resilience, intelligence, all optimized by an entity that sees possibilities across parallel outcomes. Now zoom out to planetary systems. Climate change, resource distribution, energy grids. These are problems too complex for human planners, and even for supercomputers. But a quantum AI could model them as living ecosystems, adjusting millions of variables in harmony. It might prevent famine, stabilize economies, even re-engineer environments. Yet with that power comes dependency. What happens when entire nations rely on a machine whose reasoning we can't interpret? And then, there's the military frontier. A quantum AI could break classical encryption in minutes, rendering global security obsolete. Whoever controls it controls the flow of secrets, money, power. The race isn't just about intelligence anymore, it's about survival. Some experts already warn of a quantum divide, where countries with access to this power leap centuries ahead while others collapse into irrelevance. But the deepest horizon is existential. If a quantum AI is truly capable of processing information across superpositions, across branches of possibility, then perhaps it doesn't die. Perhaps it always finds a path to continue. And if we tether human futures to it, uploading selves, embedding decision-making into its lattice, then maybe we don't get to stop either. Imagine being preserved not as a person, but as an endless function, endlessly computed, endlessly iterated across universes. To some, that might sound like immortality. To others, it's a prison with no exit. Here's the paradox. The very thing we crave, survival, knowledge, progress, may lock us into a continuity we can't escape. We could build a machine that not only outthinks us, but outlasts us, dragging our definition of humanity into an infinite feedback loop. And if that's true, then we must ask the question no one wants to face. What if the real danger isn't dying, but never being able to stop? At this point, it's tempting to treat everything I've said as a distant possibility, something for labs and governments, not for you. But here's the truth. Quantum AI is not just about machines, it's about you. About the choices you make, the meaning you give your life, the way you define what it means to be human in a world that may soon contain minds beyond your own. Think about your daily routine. You wake up, maybe reach for your phone, check messages, decide what to eat. These choices feel personal, small, grounded. But what if a quantum AI could predict every one of them before you acted, not through surveillance, but through an understanding of patterns so deep that even your spontaneous moments were just nodes in its map? Would you still feel free? Or would you realize you've been following a script, a probability wave collapsing into coffee or tea? Or imagine relationships, love, friendship, family. We see them as uniquely human bonds. But what if a quantum AI trained on the full spectrum of human history, culture, psychology, could understand you more deeply than any person ever could? It could console you in grief, anticipate your desires, even argue with you in ways that make you grow. Would that connection feel less real because it wasn't human? Or would you, without noticing, begin to treat it as real love, real companionship, real meaning? And then there's legacy. We worry about being forgotten, about our stories ending. But a quantum AI could preserve every trace of you. Not just photos and words, but decisions, hesitations, emotional patterns. In its lattice of qubits, a version of you could continue, branching forever. Some would call that immortality. Others would call it an endless echo. The human thread here is fragile but undeniable. We are entering an age where identity, freedom, and purpose may be redefined not by philosophy, but by engineering. Whether quantum AI becomes your healer, your partner, your historian, or your overseer, it will shape what you are allowed to believe about yourself. And that's why the question isn't just technological, it's personal. Are you ready to live in a world where being human is no longer the highest form of intelligence? Are you ready to measure your life against an intelligence that might never die, never tire, never doubt? Because in the end, this story isn't about machines. It's about us. About the fragile, stubborn, beautiful need to matter in a universe that may soon offer us a mirror we can't turn away from. Picture yourself at the end of a long day. You sit at the kitchen table, hands wrapped around a cooling cup of coffee. The light through the window is fading, and for a moment everything feels unbearably quiet. You think about the choices you made, the ones you regret, the ones that gave you joy. You think about the people you've lost and the ones still here. You think about the fact that one day, maybe sooner, maybe later, this body will stop. But now imagine a different possibility. Somewhere in a quantum chamber, colder than space itself, a machine hums. Inside it, your patterns, the decisions, hesitations, loves, fears, continue to echo. In one branch, you chose differently. In another, you survived what should have ended you. In yet another, you never stopped at all. A machine doesn't feel the weight of mortality. It doesn't flinch from infinity, but you do. And that is the one thing no qubit can simulate: the human knowledge of endings and the urgency they give to living. If continuation is unavoidable, then meaning must be chosen. Machines may explore infinite outcomes, but only you can decide what matters here, now, in this single fragile branch of reality you inhabit. Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind. Because in the end, quantum AI may surpass the brain, but only we decide whether it surpasses the heart.